Hey guys, we did this page in class, and this page we'll do today in the video, and this page we'll do today in the video, and this page we did in class. Okay, so each of these learning goals are equally important. All of these we know that they're going to be on the test. We just don't know which of these, like 4 or 5 questions they're going to pick. So each of these are very, very important. Okay, so let's look here at the second page. It says, understand that. So in our notebook, right? In our notebook, we should want to copy over by hand what it says there. So understand that by similarity, side ratios in right triangles, side ratios in right triangles are properties of the angles in the triangles. Are properties of the angles in the triangles leading to definitions of trig ratios. Leading to definitions of trig ratios. All right. For acute angles. So SRT 3.6. SRT 3.6. All right. So in our notebook, we've added in our learning goal. And this is why trig works. So this is something that we talked about before. Trig works because it works for any small or any big. So that's how we're able to solve for a side or an angle. So let's take a look here. It says, what is the exact value of tangent of A? Right? So we know that the tangent of any angle is opposite over adjacent. So if we are thinking about angle A, this would be the opposite side. This is the hypotenuse. And so this would be the adjacent side. So they want the tangent of A is opposite, which is 2 times the square root of 2, 22 over 9. So what is the exact value of the tangent of A? That's it, okay? So that's what the tangent means, is it's the ratio that the two sides make, the opposite and the adjacent side. Now, what next one do we have here? We've got, what is the cosine of Z? So we're going to highlight Z. What is the cosine of Z? So we'll call this opposite, this hypotenuse, and this adjacent. So what is the cosine of Z? We know the cosine is adjacent over hypotenuse. So the cosine of Z would be 12. Hypotenuse, we got nothing. So whatever the hypotenuse is. So we have to solve for the hypotenuse side. So let's see if we can figure that out. We know this is 16 and this is 12. So we can call that A and we can call that B. So here we'll call that C. So you have 16 times 16. Let's see if we can find a calculator on here quick. All right, 16 times 16 is 256. So we can take the square root of 4 both sides, and we get 20. And so some of us in class noticed, oh, I think that this is a similar triangle. That's the larger version of this triangle, a 3, 4, 5 triangle, right? If I take 3 times 4, 4 times 4, and 5 times 4, I'll get this triangle. the 12, 16, 20, right? So that means this is the cosine of z has to be 12 over 20. So what is this fraction? Well, it would mean the same thing, the cosine of z. The z has to be adjacent, 3 over 5, 3/5, right? And this is 3/5. If I divide by 4 on top and 4 on bottom, we get 3/5. Very cool. Okay, what is the sine of P? So the sine of P is opposite over hypotenuse. So the sine of P is opposite over hypotenuse. And the sine of P is 15 over 17. Beautiful. Well done. Okay, what is the perimeter to the nearest tenth? Okay, so that means I need to know all the sides. I can call them A and B if I want, or X and Y, it doesn't matter. I need to solve for all the sides. So here, this X we'll call opposite. This is the hypotenuse, so we can say that the sine of 38 is X over 18. So if we multiply by 18 on both sides, we get 18 times the sine of 38. Okay, so let's go to our calculator. So the sine of 38 times 18, 11.08. Okay, so this is 11.08. So what would this be? Now you could use Pythagorean theorem, or notice this is the adjacent side, so you could use the cosine. The cosine of 38 is y over 18. We could multiply 18 on both sides, and we'd get y is equal to 18 times the cosine of 38. All right, so let's go back to our calculator. 38 cosine times 18, 14.18, 14.18. Okay, so can we add up all of these sides to find the perimeter? Yes. Okay, so the perimeter is 18 plus 11.08 plus 14.18. And what do we get? Plus 11.08 plus 18, 43.26. 43.26. So that would round to 43.3. Nice. All right, last one on this learning goal. Complete the table given the diagram. Okay, so the sine of A is opposite, which is 9, over the hypotenuse, which is 3 times the square root of 13. Now, the math gods get very angry with this. They will not let us leave this in the denominator. Okay, but let's keep going. Cosine would be adjacent over, so that'd be 6 over 3 times the square root of 13. They're not going to let you leave that either. So we'll have to fix that. Okay, and then tangent. The tangent is opposite, which is 9, over adjacent, which is 6. Okay, so this we can do. That would be 3/2. 3/2. All right, so these other ones we have to fix. So let's go ahead and fix them. If I multiply by the square root of 13 on the top and the bottom, I'm multiplying by a magical 1. I'm not changing the value here. So I have 9 times the square root of 13 in the numerator, and in the denominator, I have 3 times 13. Okay, so this would cancel, giving us 3. So our final answer is 3 times the square root of 13 over 13. So this is 3 times the square root of 13 divided by 13. Now let's look at this one. So I'm going to multiply by that magical 1. We get 6 times the square root of 13 over 3 times 13, which would cancel, giving us 2 times the square root of 13 over 13. So 2 times the square root of 13 over 13. All right, so that definitely helps us understand that the side ratios make the angles. That's the formula. So what should we put in our notes? The sine of an angle is opposite over hypotenuse. The cosine of an angle is adjacent over hypotenuse. And the tangent of an angle is opposite over adjacent. This can be used to solve for any angle or side because of similar triangles. All right, and we really saw it in this picture where we had the small version and the bigger version. We ended up getting a bigger ratio. The smaller one, we got a smaller ratio, but it ended up just reducing to that smaller number anyway. Okay, next learning goal, use Trig and Pythagorean theorem to solve right triangle problems. All right, SR 3.8. Use Trig and Pythagorean theorem to solve right triangles in applied problems. So that means word problems. Solve for actual things out in the world, in the sky, on the ground, using Trig, not just math problems that don't have purpose or meaning. Okay, so let's see if we can do that. Here it says Jack's eyes are 5 feet above the ground. He is standing 400 feet from the base of a building. The angle of elevation of his line of sight to the top of the building is 67 degrees. How tall is the building? So how tall is the building? Well, the building is this whole thing. So the building is x plus 5. Okay, so let's go ahead and solve for x, and then we'll add 5 to get our building. So what else do we know? Well, this is a rectangle, right? So that would mean this is 400. So we have the tangent of 67 is x over 400. So we're going to multiply by 400. And we'll see what we get. All right, 94234, 94234, 94234. Now remember we were going to add 5, so that would be 947. Nice. Question number 2. Garrett makes a ramp for his skateboard in the shape of a right triangle with a hypotenuse of 2 and a leg of 1. All right, so we talked about similar triangles. That means I know that this is 30. Because when I cut an equilateral triangle in half, that ends up being 30. And so however long this was, so if it was 2, then this side's 2, that side's 2. I said it was an equilateral triangle. But notice when I cut it in half, that would make this side 1. So that's how I end up knowing that pattern. Okay, what trig ratio could he use? Well, he could use here, this is opposite, and this is hypotenuse. So he could use the sine of 30 to come up with his answer, the sine of 30. We also know in a previous goal that that is equal to the cosine of 60. So I could recognize this is 60 and recognize that's adjacent to that. So I could use cosine of 60. Can I use 45? No. Can I use tangent? No. Okay, nice work. Question 3, Michaela's shooting a paint gun at a tree. She points at G. Oh, she's at G, and she points at the target at E, assuming it goes straight. What angle? So we make X the angle we don't know. Round to the nearest tenth. So we see we have opposite. Nothing to write down for hypotenuse, but adjacent. So we're hoping you recognize we need tangent. So the tangent of an angle is 28.2 over 45.8. I need to solve for the missing angle, right? So I need x to equal the inverse tangent over that ratio, 28.2, 45.8. 28.2, 45.8. 28.2, 45.8. All right, I'm going to hit the second tangent button, right? Second tangent. I don't think that that's what I wanted. I'm going to have to try that again. All right, 28.2, 45.8. 28.2, 45.8. Second tangent. All right, 31.6. Well done. All right, question number 4. The angle of elevation from a viewer to the top of the building is 50. If the viewer is 80 feet away and the viewer's eyes are 5.5 feet off the ground, what is the height of the building? All right, round to the nearest tenth. Okay, so we can say this is opposite, and this is hypotenuse. There's nothing to, and this is adjacent. So we can say this has to be tangent. The tangent of 50 is x over 80. So when we multiply 80 on both sides, we get x is equal to 80 times the tangent of 50. $95.34. $95.34. Yet we still have to add 5.5 back in, right? So we get 180. We have to round to the nearest side, so 100.8 feet. Cool. Okay, just a couple more. There's a 30-foot long escalator that forms a 45-degree angle at the second floor. What is the closest height? Okay, so let's go ahead and call that x. We know this is opposite. Opposite the box is the hypotenuse. That's our adjacent. So we end up getting, I think we need cosine here, right? Cosine of 41 is adjacent over hypotenuse. So the cosine of 41 is x over 30. All right, so if we multiply by 30 on both sides, we'll get x is 30 times the cosine of 41. Let's try that out. Cosine times, what did I say? 30. Something went wrong. All right, let's try this again. Cosine of 41 times 30. Cosine of 41. Cosine of 41 times 30. 22.64. 22.64. What is the closest height? Looks like this would be the closest, right? Nice. All right, a picture is showing a hamster climbing down a ramp. This is 40. This is 15. What is the distance he has to travel? So we're going to make x what we don't know. So this would be opposite. Opposite the box is the hypotenuse. So it looks like here I need sine. The sine of 40 is opposite over hypotenuse. So the sine of 40 is opposite is 15. Hypotenuse is x. All right, now we're going to do the Lynch swap. We're going to swap places here. It's totally okay to do. It's just kind of a shortcut. And then we're going to go looking for our answer. So we get 15 over the sine of 40. None of our choices are this. So I actually have to tell you a new term. 1 over the sine of 40 is the same thing as cosecant 40. So this would be the same thing as saying 15 times the cosecant of 40. So I'm looking for that. 15 times the cosecant. Okay, there's my answer. I haven't talked about those signs, but you may see them on your calculator. Well, maybe if I have time, I'll talk about them in class. All right, last one. The diagram shows a ramp connecting the ground to a loading platform 4.5 feet off the ground. The ramp is 11.75 long. Determine to the nearest degree the angle of elevation. Okay, so we're going to call that x. This is opposite. This is opposite the box. Looks like we need sine, right? The sine of angle x is opposite over hypotenuse. So the sine of angle x is 4.5 over 1175. All right, so we're going to take the inverse sine of both sides, and we'll get 4.5 over 1175. 4.5, 1175. 4.5, 1175. Second sine, 22.5. 22.5. I'm going to round to the nearest degree, so that will be 23 degrees. Well done, guys. See you next time.